All right, today we're looking at FRQ9. So let's go ahead and get to work. A function f has a derivative of all orders x equals 0. Let p sub n of x denote the nth degree Taylor polynomial for f. It is known that f of 0 is negative 4, and that the p1, which is the first degree Taylor polynomial, is 1/2, or of 1/2 is equal to negative 3. Show that f prime of 0 equals 2. This seems really weird to start out, but let's start with this. This is saying the first degree Taylor polynomial. So p1 of x is equal to, well, that says it's the Taylor polynomial with the first degree centered at 0. So that means it's f of 0 plus f prime of 0 times x to the first power. And that's all we need, because this is p1. Well, now we're saying that p1 of 1/2, we know that that is equal to 3. So we have 3 is equal to f of 0 plus f prime of 0 times, and then what we're plugging in to get, sorry, not 3, negative 3. What we're plugging in to get negative 3 is 1/2. So now it becomes a little clearer. They tell us what f of 0 is, and we want to show what that f prime of 0 is equal to 2. In reality, we're just finding what f prime of 0 is. So we have negative 3 equals negative 4 plus f prime of 0 times 1/2. So add 4, we get 1 is equal to f prime of 0 times 1/2. Divide by 1/2 or multiply by 2, and we get 2 equals f prime of 0. That's all we needed there. And so this gives us 2 points. 1 point for figuring out what p1 of x is, like using this equation. It says uses, so you may not have had to write this, but you definitely needed to use this equation right here. And then 1 point for verifying, so like showing your work by plugging in the values. So that's all of this stuff right there. So 1 point for that. All right, part 2 I feel like is the most straightforward of these parts. We know f of 0 is negative 4, f prime of 0 is 2, f double prime of 0 is negative 2/3, and f triple prime of 0 is 1/3. We want the third, or the third degree polynomial. Pretty simple. p3 of x is f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 times x cubed over 3 factorial. That's the third degree Taylor polynomial, and now it just comes down to plugging everything in. So f of 0, that's negative 4. F prime of 0, that was 2. F double prime of 0, they tell us is negative 2/3. So I'm going to go ahead and start doing some simplifying. So negative 2/3 over 2 factorial should give us, let me do minus 1, or x squared over 3. Okay, and then plus, they tell us f triple prime of 0 is 1/3, so 3 factorial is 6, so that's plus x cubed over 18. And there's our third degree Taylor polynomial. This is actually 3 points. 1 point for the first 2 terms, 1 point for the third term, and then 1 point for the fourth term. Pretty simple. Depending on the terms you got, that's the points you got. Now, we're going to use this in the next problem, so remember that. We have this equation. H of x has the first derivative given by h prime of x equals f of 2x. So, real quick, the first derivative, h prime of x, is equal to f of 2x. Remember, this is just telling us to plug 2x into f. Okay? It is known that h of 0 equals 7. Find the third degree Taylor polynomial for h. We can find h prime, and then get h. How are we going to do that? Well, to go from h prime to h, we're going to integrate. So our first step is figuring out what h prime is. Well, h prime of x is f of 2x, and f of 2x is approximately that polynomial we just had, this one right here. So negative 4 plus 2x, sorry, not exactly. It's going to be the last polynomial with 2x plugged in. There we go. Minus 2x squared over 3 plus 2x cubed over 18. So that's what it tells us right here, that h prime of x, the derivative of h, is equal to f of 2x. So let's go ahead and simplify this real quick. Negative 4 plus 4x minus 4x squared over 3 plus 8x squared, x cubed over 18. 8 over 18 simplifies down to 4 over 9. There we go. Ooh, that's nice. We could pull out a 4 from everything. Okay. Now, let's get to the next part. The next part tells us that we want to find h if we know that h of 0 is 7. Well, let's first figure out what the general form of h of x is. Well, h of x is going to equal the integral of f of 2x dx, which means we're going to integrate this. What's the integral of negative 4? Well, that's negative 4x. Integral of 4x, that's 4x squared over 2, or 2x squared. Integral of 4x squared over 3, that's 4x cubed over 3 times 3, or 4x cubed over 9. Integral of 4x cubed over 9, that gives us 4x to the 4th over 4 times 9. The 4s will cancel, and so we get x to the 4th over 9. And then, because we integrated, plus c. And this is where that h of 0 comes in. So we can say, okay, to find out what c is, we say h of 0 is equal to negative 4 times 0 plus 2 times 0 squared minus 4 times 0 cubed over 9 plus 0 to the 4th over 9 plus c. And we're going to start canceling things. And so we end up with just 0, 7 equals c, because all of these become 0, and this one is equal to 7. So, let me give myself some room here. Well, I'll just do it off the side. So we end up with this as our final answer. H of x is equal to negative 4x. Well, let's start with the constant. Easier to start with the constant. It's equal to 7 minus 4x plus 2x squared minus 4x cubed over 9 plus x to the 4th over 9. That's what you would assume is your final answer. But this is where they get people. And this is probably only going to be, or would only be 1 point, but this is not our final answer. Because we have to remember what it asked us. Find the third degree Taylor polynomial. Our polynomial is currently 4th degree. So we need to eliminate this term for our final answer. And there's our final answer. 7 minus 4x plus 2x squared minus 4x cubed over 9. All right, 3 or 4 points for this part. 2 points for applying this right here. So making sure you plug in 2x into this Taylor polynomial. If you didn't plug in the 2x, you would not have gotten those 2 points. Like if you just used the Taylor polynomial you got from part B without the 2x, you would not have gotten those points. All right, 1 point for getting your constant. 1 point for getting your constant correctly. All right, and then 1 point for all the other terms in this answer. So all of these are 1 point. Okay? And there's our total point value. So 4 points here, 3 points here, 2 points there. All right. you have any questions, make sure you ask. Let me know. You can email me. It's learning, all of that good stuff. You have a great day.